Good evening, students. Am I audible?
Yes, sir.
Okay, just give me a minute. We'll get started. Yeah. So, what was the last topic we were discussing? So, what was the last topic? Can someone speak, please?
Superposition principle.
Yes, we discussed problems based on superposition, right? Then there are concepts related to electric field, right? So, shall we get started with that?
Yes, sir.
Yeah. So, I hope you're able to see my screen, right? Now,
Yes, sir.
the next question is problems based on electric field strength and electric force, right? So can someone tell me what is electric field? So what is electric field?
Region around a charge where another test charge experiences force.
Region around a charge where if you place a test charge, it can start experiencing force. Then what is electric field strength? So what is electric field strength? It is going to be the intensity of the electric field, right? Means with what extent or what force can it exert on the neighboring part, on the test charge is what is electric field strength. Right. So what is the relation between electric field and electrostatic force? F is equal E is equal to F divided by Q naught, where F will be equal to Q naught into E. Am I right? So what is going to be the unit of electric field? It is going to be Newton per Coulomb. What is the other unit for electric field? Anybody?
Volt
It is
per
also
meter.
measured in terms of something else. It's also called as volt per meter. Do you remember this? It is also
Yes.
measured in terms of volt per meter because E is also given as negative of dV divided by dr. What is this dV by dr called as?
Potential gradient.
It's called potential gradient. Anyways, so here we are going to concentrate only problem based on F is equal to Q naught into E. So in some books you would have seen something like this: limit Q naught tends to 0, F divided by Q naught. So why do we write this Q naught tends to 0? Because the value of test charge is supposed to be very, very, very small, right? So that the test charge is not able to create any influence on the source charge. So having said this, tell me how to calculate this. So there is a drop of water. Calculate the electric field required to just stop the water drop of mass 10 power minus 3 kilogram having a charge of 1.6 into 10 power minus 19 coulomb. How to do this?
We need to find the force by MA. Force is equal to M into A.
Mg will be equal to Q
Mg will be equal to the electrostatic force. So Mg should be balanced by the electrostatic force that is equal to Q into E naught or Q naught into E, whatever you call it. So mass is 10 power minus 3 into G. I will take it as 10 is equal to Q is 1.6 into 10 power minus 19 into what is the value of E? That is what we need to calculate. So E will be equal to 10 power minus 2 divided by 1.6 into 10 power minus 19. So this is going to be
Sir,
the value.
6.25 into 10 power 16.
6.25 into 10 power minus
No, sir, plus 16.
10 power 16 Newton per coulomb, because this 1 by 1.6 is something a famous expression. Where did we see? We saw it in the number of electrons that are needed to constitute 1 coulomb of charge. You remember? So correct. So 6.25 into 10 power 16 Newton per coulomb. Correct. So is there anyone having doubt in this? Shall I proceed? Shall I proceed?
Yes, sir.
Good. So tell me. Okay, this slightly higher level not needed. This kind of problems will not come. Again, mass. Okay, we did problem based on mass. Same logic. This is important. So an electron, there's something similar to your textbook problem. An electron moves a distance of 6 centimeter when accelerated from rest by an electric field of 2 into 10 power 4 Newton per coulomb. Calculate the time of travel. So how do you calculate it? So initially the object is at rest and distance traveled is 6 centimeter. That is going to be 6 into 10 power minus 2 meter. When accelerated from rest by electric field strength, so E is equal to 2 into 10 power 4 Newton per coulomb. Right? Calculate the time of travel. So what is going to be the time of travel? So mass is given as 9 into 10 power minus 31 kilogram. Charge is given as 1.6 into 10 power minus 19 coulomb. Right. How do I frame the mathematical equation?
Sir,
S is
first
equal
Sir,
to
AC equal to half 80 square.
ut plus half 80 square. U is 0, which implies S will be equal to half 80 square. So half into what is the value of A? We know that QE is equal to MA. So A will be equal to QE divided by M. So QE divided by M into T square. So all the parameters are known in the question. So what is the distance? 6 into 10 power minus 2 is equal to half into what is the charge? 1.6 into 10 power minus 19 into what is going to be the electric field? It is 2 into 10 power 14 divided by the mass is going to be 9 into 10 power 31 into T square.
So 2 into 10 power 4.
Answer, Ada.
Sir, electric field strength. 2 into 10 power 4, sir.
Oh, I wrote 14. Sorry. Okay, Vapa. Remaining things you guys can calculate. No, so calculation part alone, I'm not going to do. Anyways, so I told you solutions are here. You can always have a look at the calculation part and do it on your own. My concentration is only going to be on concepts. Shall I proceed? Is there anyone who's not clear? Okay. This is a textbook problem. Tell me how to do this. An electron falls through a distance of 1.5 centimeter in uniform electric field of magnitude 2 into 10 power 4 Newton per coulomb. The direction of the field is reverse, keeping its magnitude unchanged, and the proton falls through the same distance. Compute the time of fall in each case. Contrast the situation A with that of a free fall under gravity. This is exactly your textbook question. I need discussion. So how to proceed? An electron falls through a distance of 1.5 centimeter in uniform electric field. If an electron, tell me logically, if suppose there is a plate like this, electron is supposed to travel in this direction, then what charge should the top plate have and what charge should the bottom plate have?
top plate should
The
have
top
negative
should be
charge.
negative.
Negative, because it can repel the electron, and the bottom one should be positive. So So what is going to be the direction of electric field? It is going to be from the positive to the negative charge. And remember here, they told it travels in uniform electric field. Okay. Can you guys tell me what is the source of a uniform electric field? Who can generate a uniform electric field?
Sir, a plate, infinite plate carrying charge, uniform
Yes.
charge.
Yes. So that is the major source of uniform electric field. That is the one used in parallel plate capacitors also, right? That is why I drew the parallel plates. Hence, I can confidently say that the electric field is going to be uniform. So when that is the scenario, calculate the time of fall in each case. How do I calculate the time of fall? So generally, when they say falls through a distance, means u can be 0. It means it is dropped from rest. So S is equal to half AT square. Can I say that? So how much is the distance between the plates? It is going to be 1.5 centimeter. So 1.5 into 10 power minus 2 is equal to half into. By now you would have understood how to write acceleration in terms of electric field. Can I write it as Q into E divided by M? Remember this, a famous expression. Okay, can I write it as Q into E divided by M into T square? Q is known, E is known, M is known, calculate T. So T will be equal to square root of, see, for example, if I leave it as S itself, I'll tell you how to think. Suppose I leave it as S itself. Can I say it is going to be Q into SM, sorry, root of 2 into SM divided by Q into E. This is the time taken by the electron. Guys, are you able to understand? Now
Yes,
the
sir.
question. Now the question is, read the second part. The direction of the field is reversed, keeping its magnitude unchanged. Means this is given positive charge, this is given negative charge. Only then a proton can travel in the downward direction. Because proton travels in the direction of electric field, whereas an electron travels in the direction opposite to the electric field. So if I calculate the time taken by the proton, what will I get? Logically tell me, root of 2s into m divided by q into e. Now, tell me a point among TE and TP, what are the parameters that is going to change? Square root is same.
Mass.
Mass of whom? Mass of the electron.
Yes, and the proton.
What about the charge of electron and charge of proton? They both are
Same.
same. So what is, which one is heavier?
Proton.
Proton. So what can you conclude? The time taken by proton is directly proportional to mass of proton. Time taken by electron is proportional to square root of mass of electron. Which one will take more time?
Electron.
Proton will take more time. Because proton is heavier. Right? Okay. Now they are asking contrast is tell me, any doubt?
Sir, proton should, if it's heavier, it should take lesser time of it.
But see. But it's directly proportional to mass. You know what is happening? You're thinking in terms of gravity.
Yes. Sir.
So when you think in terms of gravity, what will happen is S is equal to half gt square. So T will be equal to square root of 2s divided by g. So if that is going to be the case, in the case of gravity, mass does not play an important role at all. What is important? The distance the object is traveling and the acceleration under which it is traveling. Acceleration due to gravity. So that is why the next part of the question they have told, contrast the situation with that of the free fall under gravity. So what would have happened under free fall condition? What can you conclude? They both are going to travel.
Same.
Same.
Sir,
Yeah, tell me.
Yes, sir.
sir, in case of electron, will you take a charge to be negative?
We don't do. Now, if you take charge to be negative, then square root of negative value, I need to use complex numbers.
Okay, sir.
Why didn't I take charge to be negative here? Nitish, you already told the answer last class. You are the guy who answered. Because I'm dealing with electric field here.
Yes, sir.
Electric field, I've already assigned the direction. Then why would I be concerned about the charge? A sign of the charge.
Yes, sir.
Urvala, if you wanted to take minus, you should have put a minus here and a minus here. Yeah. Because the electron is traveling in the direction opposite to electric field, means it is decelerating. That is also another logic. That is the reason why it is taking. Yeah,
More.
the electron is decelerating. Are you able to understand?
Yes, sir.
So these are all different ways of thinking. Okay. So mathematically, you can check all these points, right? So this is all about electric field. Okay. Now we'll calculate electric field due to point charges. What is the electric field due to a point charge, guys? So if there is a point charge here, and due to this point charge, if I want to calculate the electric field at a point P, which is at a distance R, then what is going to be the electric field at point P? It is going to be Q divided by 4 pi epsilon naught R square. Am I right?
Yes,
You know
sir.
this. Now the next question is, if I have multiple charges present in a system, then I can go with the concept of principle of superposition. It's the same logic again, except the fact that the net electric field is going to be equal to the electric field due to the first charge, second charge, plus so on till nth charge. So I'll just be quick. If you look at the language that they will use when a question is framed based on force and electric field is, when they use the word force, they use the word preposition between. Force is always calculated between the charges. Whereas if they use the word electric field, they'll say electric field at a point. So they'll use the preposition at. Okay. So they cannot ask calculate the electric field between the charges. Grammatically wrong.
Sir,
Tell me.
sir, but they can also ask calculate the force experienced by a charge kept at this point in uniform electric
That
field.
is
So that
actually happening between or no. They'll not use the word calculate the force experienced by a charge. They'll not say like you're saying calculate the force experienced by a charge placed at this point. Is that what you're trying to say?
yes, sir, placed at a point where the electric field is.
But when you're trying to do it, no, how will you solve it actually? So you will solve it by calculating the force between the charges. Why I use the word between is because if you see there are only two formulae till now, whichever we discussed. One is based on Coulomb's law, right? So for me to apply force, how many charges do I need? Q1, Q2 divided by 4 pi epsilon naught R square. I need two charges. That is why I'm using the word between. Okay. Whereas if I need to calculate electric field, how many charges are needed? Q divided by 4 pi epsilon naught R square. So only one charge is needed. That is why they'll ask calculate the electric field due to a charge at a given. Means the electric field is created by the charge. Whereas when you talk about the force is created by the neighboring charges. So electric field is independent of the neighboring charges. If you have one charge that can generate a value at a given point. That is what I'm trying to say. Think about it, you will be able to understand. Okay.
Sir.
Tell me.
Sir, what will be the grammar used when electric field intensity is given? Like
electric field?
Intensity at a point or between?
Electric field electric field intensity thanda. Electric field intensity, electric field strength, and electric field all mean the same. When they say calculate the electric field, calculate என்ற word வந்துருச்சுனாலே, it is electric field intensity only because intensity can be calculated. Electric field cannot be calculated. Electric field is just a region. புரியுதா?
Yes, sir. Okay, sir.
Yes. So with respect to your physics, if they use the word calculate the electric field, indirectly they're asking only the field intensity or field strength. So that is how the questions will be framed also. So now we can start thinking about it. Okay, I'll come to this. Now see. There are 2 point charges, 2 into 10 power minus 7 coulomb and 1 into 10 power minus 7 coulomb, which are placed 1 centimeter apart. What is the magnitude of the field produced by either of the charge at the site of the other? They use the word at. Okay, what is the meaning of this question? Can you tell me? Can someone tell me what are they trying to ask us?
Sir, field of A at B and field of B at B.
That's it. So at B, who will generate the electric field? The charge at A. So electric field at B, correct? Is equal to the charge at A divided by 4 pi epsilon naught R square, correct? So 1 by
Yes,
4
sir.
pi epsilon naught, 9 into 10 power 9 into the charge at A is 2 into 10 power minus 7 divided by R square over 10 power minus 4 meter square. Because 1 centimeter is 10 power minus 2 meter.
Meter.
So everything is converted to standard units. So it is going to be 18 into 10 power 2 into 10 power 4, which is going to be 18 into 10 power 6 Newton per coulomb. Clear? In a similar way, I'm giving you 1 minute time. I want you to calculate the electric field due to B at point A and tell me.
Sir, it would be just the half.
What is the answer? 9 into 10 power 6.
10%.
9 into 10%.
Correct. So it is going to be QB, which implies EA will be equal to QB by 4 pi epsilon naught R square. See, only thing you need to be concerned about is, since you're writing a descriptive paper, be clear with your notations. Your answer might be right, but be clear with your notations. So 9 into 10 power 9 into 1 into 10 power minus 7 divided by 10 power minus 4. This is going to be 9 into 10 power 6 Newton per coulomb. That's it. As simple as that. Right. Okay. I just have a question. So since both are positive charges, can you tell me the direction of electric field due to A at point B? Right
Away
or
from
left?
right.
So this, it is the direction of electric field at point A, and this is going to be the electric field due to charge at point B. Simple question. Right. Next. The next set of questions that we need to answer is, continuous charge distributions, right? See, we had been dealing with point charges. When we speak about point charges, you can apply Coulomb's law to calculate force, and you can apply the same Coulomb's law divided by Q naught to calculate the electric field, right? So where do you use this continuous charge distribution? In the case of Gauss law, right? See, one of the ways of solving a problem is by integration, but integration technique is not a part of your syllabus. So we mainly learn the concept of continuous charge distribution only to apply it at the Gauss law concept. Am I right? So having this in mind, can you tell me what are the 3 types of charge distributions that we know? One is volume charge density, which is applicable for 3-dimensional object. And the second is surface charge density, which is applicable for a 2-dimensional object. And the third is linear charge density, which is applicable for a 1-dimensional object. Yeah, tell me. So volume charge density, how do you define it? The amount of charge per unit volume. What is going to be the surface charge density? Amount of charge per unit area, and amount of charge per unit length is called as the linear charge density. So you know the unit: coulomb per meter cube, coulomb per meter square, and coulomb per meter. Okay. Having said this, we shall get started with the problems. So charged spherical conductor has a surface density of 0.7 centimeter square. Now, when its charge is increased by 0.44 coulomb, the charge density changes by 0.14 coulomb per meter square. Find the radius of the sphere and the initial charge on it. Can you do this? So let's take the given data. Who can help me solve this problem? Who wants to try?
Sir, sigma 1 into A1 is equal to sigma 2. Right?
Are you sure? Tell me.
Yes, sir.
Sigma 1 into A1 is what charge, no? Correct, Ada?
Yes, sir.
Now my question is, if the charge is going to be same, when its charge is increased by 0.44 coulomb means, are you saying that 0.44 coulomb is not held by the second case? Charge has changed, no? Are you able to understand?
Sir,
No, sir, where sigma 2 is addition, like it's not just 0.44. It's addition of the previous charge as well.
Think about this problem. What would have happened?
So the area wouldn't change, right? So it would be sigma 1 by q1 equals to sigma 1 by q2.
So because they didn't speak. When its charge is increased, then the charge density, find the radius of the sphere and the initial charge. So I hope you're able to understand what is not changing. Sorry.
Yes, sir. Understood.
Understood? Yeah. So sigma is equal to q by a. So sigma 1 or q1 divided by sigma 1. Can I write it like that? Okay, I'll write it like this. Q1 divided by A1. What is the value of Q1? I don't know. I'll call it as Q. Divided by, what is going to be the area? 4 pi r square. It's a spherical conductor. Right? So what is going to be the value of sigma 2? Q plus 0.44 divided by 4 pi r square. Can I divide both? Sigma 1 by sigma 2 is equal to Q divided by Q plus 0.44. So sigma 1 is 0.7, sigma 2 is 0.14, Q divided by Q plus 0.44. Right, it is going to get cancelled twice. Is that happening? No. No. I'm sorry, it's my mistake. This will cancel. So 0.7 by 0.14. So I can write it as 70 divided by 14 is equal to Q divided by Q plus 0.44. So it's going to cancel it 5 times. So which implies 4Q plus 0.44 into 5 is how much? Okay, 5Q plus 2.2. 2.2.
Yes, sir.
Okay. So 4Q is equal to minus 2.2. So what is the value of Q? Minus 4. Minus 0.55. Minus 0.55 Coulomb. Charge is given. Initial charge is 2.2 Coulomb. Where did I go wrong? Is there any mistake in the calculation? 0.7 by
Sir, in the
0.1.
LCM part, sir.
LCM part leda tappa. Where?
Sir, that converting that 0.7 and 0.14. 70 by 1.4 it should come, sir. You have just taken as 14 itself, sir.
Yeah, 70 by 14 only, correct then? Into 100 by into 100.
Oh, okay, sir.
That's tappilla. So 5Q plus. So why did they get 2.2? Let me check.
Sir,
Sorry,
I have a doubt.
I read the question wrong. It is not changed to. I'm sorry, it is not changed to, changes by. Means to that 0.7, that 0.14 should get added. So sorry, it was my mistake. Sorry. Yeah, somebody was asking it out.
No, sir, I had the same doubt. That's why.
Yeah, I didn't see that where they were discussing. No, I missed to see the word pi or new value. Sorry about it. So we'll do it again. 0.7 divided by, what is going to be the new value? 0.7 plus 0.14 is equal to Q divided by Q plus 0.44. So 0.7 divided by 0.84 is equal to Q divided by Q plus 0.44. So can I write it as 70 by 84 is equal to Q by Q plus 0.44? So this will go 5 times, this will go 6 times. Am I right? So 5Q plus 2.2 is equal to 6Q. Now we got it. Now Q is equal to 2.2 Coulomb. Right? So find the radius of the sphere. How to find the radius of the sphere? Take sigma 1 Q divided by 4 pi r square. So sigma 1 is 0.7 is equal to Q is 2.2 divided by 4 pi into r square. Rearrange in calculator. That part I'm leaving it. Okay. I hope the concept is clear, right? So next time this kind of a problem, you will be able to hold it. I mean, handle it.
Yes, sir.
So this kind is not needed. Next is problem based on dipole moment, dipole field, and torque on a dipole. Right? What is the dipole moment? First of all, what is the dipole? Two charges of equal magnitude separated by a very small distance is what is called as an electric dipole. So generally, what is that small distance in terms of? It is in terms of angstrom or nanometer, right? So based on this, there is something called as dipole moment. So what is dipole moment? P is equal to Q into 2A, whereas Q is what? It is the magnitude of either of the charges into 2A is the distance of separation between them, right? Now, if I calculate the electric field at axial point, what is going to be the value?
2 kp by RQ.
So 2 kp divided by RQ. What about the electric field due to the equatorial point?
Minus KP by R cube.
Minus kp by R.
Kp by R. Why is that minus sign coming?
The resultant is opposite to the direction of dipole.
Direction of
The dipole.
dipole direction கிடையாது.
Electric field.
Dipole கிடையாது. Correct. Dipole
Dipole moment.
moment.
Dipole moment.
So when you calculate at the axial point, the electric field is in the direction of the dipole moment, whereas when you calculate at the equatorial point, it is always in the direction opposite to the dipole moment. Right? Similarly, what is the torque experienced by dipole when it is placed in uniform electric field? Torque is equal to P vector cross E vector, or this can also be written as
P sin
P sin theta. Right? And see, this is when you place it in the uniform electric field. Am I right? So if you take a dipole and place it in non-uniform electric field, what would have happened?
It would experience translatory force.
Yes, force plus torque will act on the object. Whereas when you place it in uniform field, it is only going to be torque. Clear? So having this in mind, let's solve the problems. Two charges, one of plus 5 microcoulomb and other minus 5 microcoulomb, which are placed 1 millimeter apart. Calculate the dipole moment. Answer: E is equal to magnitude of either of the charges. So 5 into 10 power minus 6 into 10 power minus 3. So 5 into 10 power minus 9. What is going to be the unit?
cm.
Coulomb meter. Common mistake that happens is people write it like this. What is the difference between both?
Centimeter and kilometer.
Yes, this is coulomb meter. This will become centimeter. So be very cautious while you are writing the units. I've seen this mistake, okay, in papers. So be very careful.
Sir,
Tell me.
sir, here could you tell where the stable equilibrium and where unstable equilibrium is?
Sure. So if you place it in the electric field, okay, you can place, see, if this is the electric field, okay, you can place the dipole inclined at an angle like this. Right? Can you tell me what is the direction of dipole moment? It is from
Negative charge.
Negative to positive.
the positive charge. Right? Now, if this is the electric field, if the negative charge is here and positive charge is here, can I say this is going to be the direction of dipole moment?
Yes, sir.
Right? So here, if you see, what is the value of theta?
0.
Yes, because torque is equal to PE sin theta, where theta is the angle between P vector and E vector. If theta is equal to 0 degrees, if this kind of a scenario occurs, then you call it as stable equilibrium. Because last class I explained what is stable equilibrium. When you disturb an object, if the object takes a turn in the direction, if it takes a turn exactly in the direction opposite to the disturbance that you created, it's stable equilibrium. Means it will go back to its original position. Whereas if it is like this is the direction of dipole moment. Now what will happen is, here theta is equal to 180 degrees. Mathematically sine 180 is 0. But if you disturb this object, right, it will take a 180-degree turn and then come back to the equilibrium position. Because here it is at equilibrium, no doubt. Equilibrium means it's not accelerating, but it is not stable, it is unstable. So did I answer your question?
Yes, sir. Got it.
Got it? Yeah. So please make a note. You don't need this detailed explanation in the paper. This will mostly be a 1-mark question. So theta is equal to 0 degrees. Theta is the angle between dipole moment and electric field. If theta is equal to 0 degree, stable. Theta is equal to 180, unstable. That's it. Right? So apart from this, I hope everybody is clear with this problem as well.
Yes, sir.
So an electric dipole, when held at 30 degrees, so theta is equal to 30 degrees, and underline the word with respect to the uniform electric field of how much value? 10 power 4 Newton per Coulomb, experiences a torque of 9 into 10 power minus 26 Newton meter. Calculate the dipole moment. So what is the answer? Torque is equal to PE sin theta. What is the value of torque? 9 into 10 power minus 26 is equal to P is what we need
Sir,
to calculate.
18 into 10 per minus 30.
Is that the answer? And sin 30 is half. So 18 into 10 power minus 30 Coulomb meter. Right? That's it, no? So let's check if the answer is right. 10 power minus, okay, they wrote it as 1.8 into 10 power minus 29. So that's same. Right? Simple problem, no? Shall I proceed? Answer this. An electric dipole consists of two charges, two opposite charges of magnitude, 1/3 into 10 power minus 7 Coulomb. And they are separated by a distance of 2 into 10 power minus 2 meter. The dipole is placed in external electric field of value 3 into 10 power 7 Newton per Coulomb. What maximum torque does electric field exert on this dipole? Simple.
Sir, 0.02
They use the word maximum
Newton
torque.
meter.
When is maximum torque possible?
Theta 90.
Because sin 90 has the maximum value. So where else does this concept of maximum torque come in your physics? It comes in some other chapter also. Let's see. How many of you know this? I'll give you the in 4th chapter.
Magnetism.
Magnetism is the name of chapter. Which concept does it come?
Rectangular coil. Torque experienced.
Galvanometer. Okay. So torque is equal to PE. Sin 90 is going to be 1. So P is how much term? 1/3 into 10 power minus 7 into 3 into 10 power 7. Beautifully, they are getting cancelled. Into E. E is how much?
Sir, you have to do Q into 2D, sir.
Okay, but anyways, so what I'll do is 2D, I'll write it here. So I'll write 2D here. No, answer will be 4 into something.
Sir,
But the distance
2D
is only 2.
Sir,
sir,
so
2D
wouldn't
is-
it be 0.02 Newton?
That's right.
sir,
2 into
here,
10 power minus.
sir, here distance of separation is 2 into 10 power minus 2. That means 2D
That is 2D. That is
Yes, sir.
2D. That is 2D.
Okay, sir.
Okay. Yeah, that is another important point. There's another place where students make mistake. When they give you the distance between the charges, right? It is equal to 2a. 2a or 2d, however you have learned. Okay, it is the distance. So charge multiplied with this distance is going to give you the dipole moment. I hope the answer is clear, no? 2 into 10 power minus 2. Simple. Next, calculate the electric field due to an electric dipole of length 10 centimeter having charges 1 microcoulomb at an equatorial point 12 centimeters from the center of the dipole. Kp divided by r cube. So 9 into 10 power 9 into what is the value of p, guys? 10 power minus 6. Cos p is equal to what? Q into 2a. Q is 10 power minus 6 into. How do you calculate the length? The 2a is how much? It is 10 into 10 power minus 2 divided by. What is the value of r cube here? 12 into 10 power minus 2, the whole cube. Can I say that? So this is going to be 9 into or 90 into 10 power 9 into 10 power minus 6 into 10 power minus 2 divided by 12 into 12 into 12 into 10 power minus 6. This and this will get cancelled. 90 I can cancel with 3. So this 10, 4. So can I write this as 5 and 6? So can I write it as 10 square, that is 10 square into 10 square into 10 square into 10 power 3 into 10 power minus 2 divided by 4 into 4 into 6. I'll tell you what I did. This 10 power 9 is there, no? And I have a 5 here. So 10 power 9 is there, no? I split it as 10 square into 10 square into 10 square into 10 cube into 10 power minus 2, the last one that is left out. Why I wrote it as 10 square is because 4 will cancel this 25 times. Here it will cancel this 25 times. Right. So now my job is easy. 25 into 25, 625, 625 into 5 is? How much is it? 3125. Yeah? So 3125 into 10 power 2 and 10 power minus 2 will get cancelled into 10 power 3 divided by 6. Now it is easy for you. No? 520 point, it's approximately 521.
Sir, I think it's
You think? Is there any mistake?
sir, I think it's approximately 10 power 6.
Which one?
Sir, because 5 upon it'll be 16 into 6, right?
Is there anything, any number that I missed? 16 into 6, where did it come from?
Sir, 4 into 4, 16 and
No, I didn't want to do that. No, I didn't want to do that. That's why I cancelled it, because I'm comfortable multiplying rather than dividing unnecessary values. That is why I wrote it as 10 square into 10 square into 10 square later. So that I'm left out
sir,
only
it's
with.
it's correct only, sir. It's correct.
Yeah. So it will be 521 approximately. 4.096. Where did I go wrong? 0.12 plus 1 minute.
Sir, they took r square minus a square
So-
whole power 3/2.
I think
They
it has to
didn't
be
do the-
5, sir.
Which one, ma?
In second line, or like in denominator, 12 into 5.
Why 5?
Because they are asking A, right? So 10 by 2, right? No, sir.
Calculate the electric field due to an electric dipole of length.
Yeah, yes, sir. 10 is actually 2A, no, sir.
10 is 2a. But inge applied lama. P I applied, no? P is Q into 2a. Why do I need to take it again? So one thing they did is, here if you see, no, they didn't do the approximation.
Sir, is it because A and R are very close to each other?
They're very close, no? That is why they took it like that. They took it like that, but this kind of a problem is generally not asked. Okay. But you understood how to proceed. This concept is not a part. Don't worry about this. This kind of question will not come in your books. You will not take it as R square minus A square. You will be asked only based on P divided by 4 pi epsilon naught R cube. So that is what they did in the solution. You see, they took it as 12 square plus 0.05 square. Okay. So that is why our answer is somewhat close to it, 5.20 into 10 power 5 electric field only, Newton per Coulomb.
Sir.
Tell me.
Sir, but technically we aren't supposed to do this approximation because R is not greater than this.
That is what I'm saying. This kind of a problem will not come. We are not supposed to do. What they did is right only. I'm not saying it is wrong. Because this is 10 and this is 12. They are comparable values. You can do it only when R is very much greater than A. Had this been in terms of some nanometer or angstrom, then we could have done it. Okay.
Okay, sir.
Yeah, that is what I'm saying. I'm not saying what we did is right. We should have actually taken R square minus A square the whole power 3 by 2, but this formula is not a part of your syllabus, is what I'm saying. Okay. So next is the last concept that is based on electric flux and Gauss law. So can you tell me what is electric flux? It is the dot product of E vector dot A vector, which is going to be E into S into cos theta. What is E? Electric field, and S stands for the areal vector through which the electric field lines are to be calculated, and theta represents the angle between the electric field and the areal vector, right? So what does Gauss law state? The surface integral of E vector dot ds vector is equal to Q divided by epsilon naught. What is the value of Q? It is the charge enclosed by the Gaussian surface. Right? So charge enclosed by the Gaussian surface divided by epsilon. Right? Now, tell me how to solve this problem. Electric field is 6i cap plus 3j cap plus 4k cap. Calculate the electric flux through a surface area which is 20 units in YZ plane means what?
The aerial vector
It has to
I
be
think,
exact.
The aerial vector's direction should be exact.
I
So
can.
I can.
Yes.
Okay. So what is going to be the flux? Flux is equal to E vector dot A vector. Here I confidently wrote it as E vector dot A vector because electric field is a constant. Area is also a constant. How did I say they are constant? Because electric field only has the coefficients as numbers. So whenever it is a constant, you can just multiply. Answer will be 120. What is going to be the answer? 120
Units.
Newton. Oh, units only. They didn't give us anything. So 120 units. That's it. So what is the SI unit of flux? It is Newton meter square per Coulomb. Right. Or what is the other unit for flux? Newton meter square per Coulomb is one of the units of flux. What is the other unit of flux?
Be
Is voltmeter. Because Newton per Coulomb is volt per meter into meter square will give you voltmeter. Okay. Next. A circular plane sheet of radius 10 centimeter is placed in uniform electric field. It's placed in uniform electric field of magnitude 5 into 10 power 5 Newton per Coulomb, making an angle 60 degrees with the field. So there is a circular plane sheet, right? And that circular plane sheet is placed in such a way that it is making A circular plane sheet of radius centimeter placed in uniform electric field of this much value, making an angle 60 degrees with the field. Calculate the flux through the sheet. Can you tell me how to calculate?
So the angle made by the aerial vector will be 90 minus 60 degrees.
That
It
is
will
right.
become 30.
This is where we need to be careful, okay? Right. This angle is 60. We need the, for us to calculate the flux, we need the angle between the electric field and the aerial vector. So theta is not equal to 60. It is some, if I take it as some alpha, then flux will be equal to E into A into cos theta. So E is 5 into 10 power 5 into area is how much? Pi into 5 into 10 power minus 2 the whole square into cos of, how much should I put the value as? 90 minus 60. So that is going to be sine 60 or cos 30. So 5 into 10 power 5 into 3.14 into 25 into 10 power minus 4 into sine 60.
Or isn't the radius 10 centimeter?
Radius is 10
Yeah,
centimeters.
yeah, sorry. So 10. So it is going to be 100. So 100 into 10 power minus 4. So answer will be 3.14 into sine 60 is root 3 by 2. Okay. That part calculated. So answer is 1.36 into 10 power 4 Newton meter square per. Next. A positive charge of 17.7 microcoulomb is placed at the center of a hollow sphere of radius 5 centimeters. Calculate the flux density through the sphere, through the surface of the sphere. Answer.
Is it 0?
So we can find electric field by sigma by epsilon naught because it is surface.
Do we need to complicate that much? What does Gauss law tell us?
Q by epsilon naught.
It tells you that if you want to calculate the flux through any surface, just calculate Q by epsilon.
Sir, I have a doubt.
If somebody
So
told
here,
that, you want here?
sir, here are we taking both the surface areas of the sphere or only the outside surface area?
Need to take the outside surface area.
Okay, sir.
Both means what are you saying? Given the thickness into consideration, is that what you're saying?
Like, yes, sir, because it's given as a hollow sphere. Should we take only the outside or both the outside and the
We
inside?
need to take only outside. Inside, we don't know, no, because they didn't give us any inner radius.
Oh, right, sir. Okay,
It
sir.
is considered to be thin. And secondly, is that you who told the answer is 0?
Yes, sir.
The answer would have been 0 had they used the word conducting.
Oh, right, sir. Okay.
Okay.
Yes, sir.
So Q divided by epsilon.
Sir, approximately 2.7 into 10 power 6.
I don't know, but so it is 17. It should be 2 point because 8.85 into 2 is 17 point something. So 17.7 into 10 power minus 6 divided by 8.85 into 10 power minus 12. So approximately 2 into 10 power 6. Correct?
Yes, sir.
So it has nothing to do with the radius because this kind of a problem is also asked. Okay, now they'll ask you what would be the new flux if the radius is doubled? What will be the answer?
Same.
It will be the same because according
The
to
charge, net charge enclosed the same.
According to Gauss law, since the net charge enclosed by the surface is still the same, it has nothing to do with the radius.
Sir, is flux and flux density same?
So here we calculated, what we calculated is flux. So according to them, flux density means flux per unit area. See, density.
So should you divide it, sir?
Yeah, see, listen to this very carefully. Okay, when they use the word density, right, in physics, density is something divided by either length, area, or volume.
Okay, sir.
So in flux density, you calculated the flux. So 2 into 10 power 6 divided by area is 4 pi r square. This part you do it. But again, the concept of flux density will not be asked. They will ask you only the flux.
Sir, I have another doubt.
Yeah.
So since flux is electric field dot area vector, right, sir? When we divide it by area, won't we get electric field again?
You will get, but thing is that cos theta you forgot, no?
Oh, yes, sir.
Because what does the definition of electric field tell you? The number of field lines passing through a surface. This is where we concentrate. But what is the important point we need to focus upon? Passing through the surface perpendicular to it. Are you able to understand? So that word perpendicular is what is bringing that cos theta into picture.
Okay, sir. Got it, sir.
Yeah. Can we try this? Like a 7. We'll do this problem and then we'll wind up. So we need to do some more problems based on Gauss law concept, applications of Gauss law. That maybe in the next class, the first 10 minutes we'll do it and then we can proceed. So shall we try this? Calculate the electric flux through each of the 6 faces of a closed cube of length L. If charge Q is placed at the center.
Q by 6 epsilon.
Sir, 1 by 6 times Q by epsilon.
So read the question. No? Calculate the electric flux through each of the 6 faces. So through the total cube, it is going to be Q by epsilon naught. But through each phase, it will be 1 by 6 times Q by epsilon naught. Provided when the charge is placed at the center. If the charge is placed at one of the vertices, then what would have happened? If the charge was placed at one of the vertices, then what would have happened?
There will be 2 cases.
What are the 2 cases?
The adjacent faces will have 0 flux through them, and the opposite ones will have 1 by 3 Q by epsilon.
Why is it 1 by 3?
So we have to integrate.
Okay, it's 1 by 24 Q by epsilon because only 1 by 8 of the flux enters the cube and it passes through the 3 faces.
Just give me a minute, I'm getting a call. Yep. Sorry, please tell me again. I didn't listen. Sorry. When it is placed, you are saying something. 1 by 3, something you are saying. When it is placed at the vertices,
1 by 24.
Why is it 1 by 24?
So because it's in a corner, only 1 by 8 of the electric flux enters the cube, and those electric flux pass through the opposite 3 faces.
Perfect. Did you guys understand what he told? Did you understand?
No, sir.
So answer would be 1 by 24th of Q divided by epsilon naught, because field lines are released in all the directions. Right. So these field lines will have contribution in how many phases? So it will have a contribution in this phase 1, because for the first phase that I've drawn, the aerial vector and the electric field are in same direction. Am I right?
Yes, sir.
Yes, sir.
Similarly, there is a phase at the back. That is 2. So through that phase, what is going to be the value? It is going to contribute to the flux. Similarly, with respect to this charge, there is a phase here. It is going to contribute to this. So how many phases is the charge at one of the corners able to contribute to? Contribute to the flux only through 3 phases. Guys, are you able to understand this point?
Sir, can you repeat?
Yes, sir.
See the answer my question. Okay, how many corners are there? Nitish, it was you who told me 1/6, right?
Yes, sir.
Why did you say 1/6? When the charge was placed at the center, why did you confidently tell me 1/6? Someone told me Q by epsilon naught, but you told 1/6. Why?
Sir, first assume to be a square, and then for a cube, 6 sides are there.
Because they use the word each of the 6 phases.
Yes, sir.
Because of the word each of the 6 phases. Had they asked the word cube through the whole cube, answer would have been Q by epsilon naught. So each means how many phases are there?
6 phases.
Otherwise, you divided with 6.
Yes, sir.
Can I say that? Now the question is, the charges are placed at the corner. So Sanjeevan told me that there are 8 corners, sir. So just like how you divided by the number of phases, now you divided with number of corners, no? 1/8.
Yes, sir. Yes, sir.
But this should further be subdivided because the charge at each corner is able to contribute to the flux only through 3 surfaces. Out of the 6 phases, if this corner is there, now I'll use an yellow color. See, okay, I'll use black use for the corner. So in the corner, this corner is connecting how many phases? The top phase, right phase, and the phase which is towards me. Purida.
Yes, sir.
So through those 3 phases, will this charge be able to contribute to the electric field, to the flux? It will not be, because electric field due to this charge is in this direction, but the aerial vector is upward, perpendicular.
Yes,
Flux
sir.
is 0. Adhe mari for the second phase, it is perpendicular, flux is 0. For the third phase, that is, it is towards me. Electric field is in this direction. Aerial vector is towards me. Again, through that also flux is 0. So what are how many sides is it able to contribute to? Only to the 3 other phases. So adanalada you should further subdivide it with 1/3. So that is why the answer is 1/24 times Q by epsilon. Think about it, you will get the answer. Think about it.
Yes, sir. I'm getting it. Yeah.
Got it? So if it is still not clear, you ask me as a first question tomorrow, I'll explain. Okay. So 7:10 now. Okay, we'll wind up with this. Okay. And then we'll get started with Gauss law based applications based on Gauss law tomorrow. And then we'll go to the next chapter. Shall we wind up?
Yes, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.